Good morning, Max sysadmin. Henry isn't here. He's absolutely gutted. He says hi, and we're going to try and fill his boots. And I'm Johannes. This is Eric.
Hi.
I joined the company last year, and let's get started. So what if we went client as code? Everything, placing all configurations, profiles, packages, our tools, rules, checks into repositories to manage a fleet of Macs with GitOps. The code would be stored in Git repositories. We would do changes with pull requests, have review processes in place, and we'd use CI/CD pipelines for the automation. Why would we do that? We've had many discussions with Mac admins lately, and one thing keeps coming up, more than half of them, is set and forget. A lot of you want to save time, and if you had perfect API or tools, you'd automate the hell out of device management. You cut down your time spent controlling, troubleshooting, and double-checking, and if you could reduce the human factor, you would see results quicker and spot errors earlier. You'd move fast without looking over your shoulders much. So the more we can define our client as code, that means we can come closer to this set and forget device management nirvana. Why else would we do it? Henry's covered reasons for that extensively in his last talk at Mac DevOps Why We Are in Vancouver. And if you're interested, you can find it on YouTube, so let's just do a quick recap. Bringing a DevOps mindset to device management is all about reliability. We make processes repeatable and automate them to reduce the risk that something goes wrong, whether that's small or epic scale. We want a stable system and resilient clients. If we commit all the changes in our device management to repositories in Git, we can get that authoritativeness that we want for auditing, because there's only a single source of truth. So for this talk, we have our very own reasons to go down this path, but you'll need a little history of Central to understand them. Central came about when Henry was with Apfelwerk, doing professional services. Osquery was just coming out, and he got really excited about it, met with his developer friend Eric, who first wrote Central as a TLS remote server for Osquery in 2015. And Santa came out around the same time and required a similar type of sync server. So they added that to Central as well and hooked it up to a Jamf inventory. And they were using Central mainly for managed services, but saw a growing interest for it and launched a company in 2019 to support customers and help users get started with Central. And while integrating new Munki features for a big client, kind of got thinking. It's funny that we actually have a pretty complete open source device management platform. There's patch management with Munki, which is best in class anyway, and observability through Osquery, and we can do hardening with Santa. So the users are mainly using Central to iron out deficiencies in their MDMs, and if we build one of our own, that would probably have potential. And there were bits and pieces of MDM in an experimental module. Even some declarative device management features we toyed around with in testing. So last year, we took the plunge and started to develop our own MDM for Central. With DDM and GitOps becoming such a trend, we are putting the concepts forwards for a fresh take on Apple MDM. So why am I telling you all this? The story about turning Central into an MDM vendor is a very long way to say we need to get ISO and SOC 2 as the station as soon as possible. We don't host data, but we get asked about ISO and SOC 2 all the time. In the long run, we want to offer a SaaS solution, so we have to get it done. And for us, formalizing our device management is an important part of this process. So here we are in our office about a month ago, thinking this is a great opportunity to push ourselves into that direction. Let's go full GitOps. Let's eat our own dog food, put Central to the test, and it's going to be client as code from now on. And they're going to be very impressed in Gothenburg, and what could possibly go wrong? Well, what could happen is there's only a little more than 4 weeks to prepare this talk, and we're setting the bar pretty high. for us, and if we fail, we have to fill 15 minutes with our shame. But it's too tempting to go and chase after that set and forget device management nirvana, full of daisy-chained automations for a little bit of applause here. And if this shall be the hill we'll die on, we'll do it here in public, and so you can see for yourselves whether that GitOps hype is real. And we're not going to go on about Central the whole time. There'll be some things that you can apply to other tools. All right. So to get started, we need to define what the client shall be. We're going to outline what broad decisions we will take and what tools we are going to use and what rules we want to set for ourselves. Like you all, we are working pretty much at capacity, so we want to keep the process lean, and let's dive into it. Our guiding light shall be stay true to the platform. We don't want to engage in an uphill battle of trying to fight it. Instead, we'll base our client on stock macOS MDM functions and complement them with best-of-breed open source agents. First of all, let's go with 3 global decisions, though. The first one is obvious. It's going to be a supervised client. The device supervision will allow us to fully control the macOS client. Our devices are organizationally owned, and the supervision provides additional control over its configurations and restrictions. Functionalities like remote wipe and restart will only be available when the device is supervised. How do we get a supervised device? We'll add them to our business manager, and we'll roll with automated device enrollment. The second big decision is that our fleet will absolutely only have modern devices. And this is great to limit the scope of this talk. So the pro tip here is if you're tired of maintaining complicated workflows for your older devices, talk to your CFO like we did and say it's just way more efficient. This conveniently removes all the headaches that we associate with older OSs, and we benefit from the advantages of having a modern fleet of devices, all Apple Silicon, T2 chip, running at least macOS Sonoma. All right, and the last decision for the client is that we'll have a strict one-to-one user-device association. Again, this is so we can keep it simple and use what the platform offers. We will authenticate the users with the automated device enrollment with our identity provider. We use the signed claims we get from the IDP to create the first user as administrator. We're not saying that this should be the only solution or your users are all admins, but it's a good way for us to simplify our day-to-day as an almost all devs company. With our basic design decisions out of the way, let's talk about a toolkit. As the classic Central cocktail of open source tools, you've probably heard us talk about it, so let's be quick. First up is Munki for patch management. Simply the best. Installs apps, reports on it. With Munki, we will control the rollout of our most critical app updates, especially of the open source agents we use. For better hard and software asset collection, we will deploy Osquery. And the information it reports is way more detailed and broad than what you can get with the standard MDM commands or DDM status reports. It also increases our capability to troubleshoot because we can run ad hoc queries. Next up is allow and block listing of applications and binaries. We have to make sure that our users do not make too many mistakes, and we'll deploy Google Santa on our machines and use Central as the sync server. Santa has an endpoint security extension that can allow block applications based on the binary hash, the certificate hash, the team ID of the signature, and the team ID and bundle ID of the signature. We're going to maintain these rules manually based on aggregations of the topmost allowed apps for the allow rules. And for the block rules, we're simply going to rely on the wise guys from security and the HR department. While we're at it, we should file a feature request for a voting system with the dev team and hope they pick up on it. Now that we've covered our open source toolkit, let's talk about standard hardening, at least for the employees that are not Central admins. It's 2023 and we're still talking about it. Firewalled, no special setup or tools. We rely on the new functionality in macOS 14 to enable it during the setup assistant. And for older OSs, we force it at a lock-in window. We'll have the personal recovery keys escrowed to Central, and to make sure that our local admins don't make very big mistakes, we need to lock down their access to the recovery OS. We're going to use recovery lock on Apple Silicon and firmware passwords on the machines with the T2 chip. And the macOS Securities Compliance Project will be our resource for building configuration profiles to harden macOS. We're going to pick some of them, for example, for a login window, screensaver, and password. The whole thing will be an ongoing process. We can add more restrictions and settings as we go and adjust the ones we have in place. All right, so we've covered broad design decisions. We talked about our tools and standard hardening, and we've got our client laid out pretty nicely, but there's one big thing missing. Can you guess? All the systems and configurations we have are great, but we need to make sure that they're active, so we need reporting. Our users are admins and can make very interesting decisions when they're left to manage their devices on their own. I think Henry meant me. We're going to use compliance checks to verify that clients stay in good shape, and we'll have two kinds of compliance checks. One will be based on Osquery queries, and they are going to be part of the query packs that we distribute. And the other ones will operate on Central's unified inventory, where the agents update device information. We'll get to this in more detail in the next part. All right, last step is we're going to talk about what's out of scope for us. We're going to ignore EDR agents and antivirus. There are good products around, but for this client, we are going to simply make sure that Xprotect and MRT up to date, and that we have Santa rules for the worst software out there. We'll also not have any bring your own or user enrollment. This would require a different workflow with restrictions on what is manageable because of the absence of supervision. It could also be managed as code, but it would be completely different client experience and ownership, and too much for this talk. So here's a summary of what our client as code looks like. Our global decisions are, we've got a supervised client, modern devices, and one-to-one user device association. Our tools are the classic mix, Munki, Osquery, and Santa. And for hardening, we've got File Vault, Recovery Lock, mobile configs. Yeah, pretty straightforward. And now I'm going to hand over to Eric, who's going to talk through the process.
Hi. So, oops, of course. Now we have to get to the how we did it, implementation details. So in order to deploy these configurations and the artifacts, we've built 3 pipelines. I'm going to show you the 3 pipelines now. We are going to start with what we call the Bootstrap package. So what is it and why do we need it? So as Johannes told you, we are using Munki to install the applications on the machines. So we have to push Munki as the first package during setup assistant using the install enterprise application command. But it's not only necessary to push Munki, we need to trigger the first run. And we didn't want to use our own custom script or hack. So we asked around, and our good friend Alistair told us to have a look at Outset. So many of you in the room know about Outset, but still the description in the project on GitHub is Outset is a utility application which automatically processes scripts and packages during the boot sequence, user logins, or on demand. So it's perfect for us because we can use Outset to do the first Munki run when the first user logs in. So now it's all about GitHub. So we need to build this package, and we need to make it so that it's reproducible, auditable, and so. So the 3 pillars of GitHub are that the configuration has to be defined as code, that we have like a repository with some protections on the branches, and finally that we have a pipeline to apply this configuration and produce the result. So we start with the code. Here we have like an example. So it's an overview of a project to build this package. We start with a config file. I don't know if all of you can see it, but yeah, there's a product ID and product version. That's what we use to as product ID and version of a big package we are producing afterwards. And these are the two products we are going to install. So there are download URLs and with there are download URLs with version numbers. So we pin the version down. Then there is an outset script. Again, very simple. We have a subfolder in the project, and we put like the script in the login privilege once folder. For those of you who know outset, this one is going to be run only one time when the first user login, and the script is that simple. We just trigger the first one, and this is going to be included as a flat package in the distribution package. Then there is a build script. So yeah, I'm familiar with Python, so we decided to build it with using Python. Here is an overview of the main key things. So the packages are going to be pushed to a S3 repository. So first we check if the package already exists. If it doesn't exist, we move on. We loop on all the configuration. We loop on the config on the packages. We include them in the main package. We add the outset package, and then we build and sign the package. And finally, we upload the package to S3. So this is the code. Now we need the repository configuration to make sure that everything is fine. So we use classic configuration with main as a production branch, and we've got basic branch protection, meaning you cannot push directly to main, and you need a pull request, and the pull request cannot be merged into main without approvals. So this is how you do your code reviews. And finally, the last step is obvious. When we are going to merge the pull request into main, we are going to trigger the build system. So how do we trigger it? There's a pipeline, and we are going to use GitHub Actions. So here in the .github workflows subfolder of a repository, we have a workflow, and we are going to have a look at it. So a workflow is composed of jobs, and jobs have different steps. The first step is usually to check out the code. Then we have a kind of ugly part, but it's well known. We want to sign the package, and in order to sign the package, we need to put a distribution signing certificate, installer signing certificate, and we need to have it with a private key in an open keychain on the machine. And the machine, I mean, this thing runs on GitHub, so this is a ephemeral virtual machine. So here is how we do it. It's sadly the official way of doing it. You put your certificate and the private key in a P12 structure. You encode it using base64. And when you run this, you just decode it. Of course, there is a password protecting the P12. So you put the P12 and the password as secrets in your GitHub workflow. You can decode it. You create a keychain. You unlock it. You import the certificate using the password as well into the keychain. And you make sure that the keychain stays unlocked. So after this step, you are going to have the certificate, and the other steps can benefit from it. Then the next step is a bit easier. We install Python, and we install the requirements for our script. And another important step is we need to authenticate with AWS to be able to upload the package to S3. And we decided to not do it like the easy way with a secret and access key ID and a secret. We wanted to do it the proper way, so this is the proper way. There is a very interesting feature of GitHub, but also GitLab, that GitHub can provide the workflow with a signed JSON Web Token. And inside the token, there is like some nice claims, like, for example, the repository name. On the AWS side of things, you can configure an identity provider that can verify the JSON Web Token signed by GitHub. and then there is an associated role that can be assumed with a web identity. And the nice thing is that the web identity policy can be configured to verify the claims in the JSON Web Token. So we can verify that it's an actual repository we're awaiting, because you don't want to allow any token signed by GitHub to assume you want only the tokens for your repository to assume the role. And once this trust is established, then you can exchange your JSON Web Token for temporary credentials, and then you can move on and use the API. So this is great because you don't need to retrieve the credentials, you don't need to have extra secrets, you just establish a trust between the workflow and AWS. And yeah, last step is we just run the build. So the end result is that we have packages on S3. And the main benefit from it is that you don't have to configure that on every dev machines or admin machines. It's up there, it's auditable, and there are code reviews. So next one is how to manage the Munki repository itself, because yeah, we have packages we need to distribute. So first we will have a quick thing about the package selection. Yeah, so it's a very limited package selection. I mean, we didn't have like a lot of time to build this whole client. Patch management can be a bit complex for user-facing applications. There's debates about if you want to do it with Munki or if you want to use the built-in mechanism in the apps. So we left it as a work-in-progress item, and we are going to concentrate on the agents we actually require for the client. So it's all going to be Munki, Santa, Osquery, and the 2 enrollment packages for them. Obviously, work in progress. We probably will have to revisit that and add more apps in there. The inspiration for the pipeline, when we looked at what kind of workflows were already in place, existing for managing Munki, we found a string of projects. And I think, but I'm not the best historian here, I think that it all started with the release of auto package tools from Facebook, like already quite a time ago. And then Gusto released a nice GitHub Actions integration of a Facebook tool. And we got our inspiration from, we took actually the repository from AdaElf. It's kind of a compilation of these tools that was released by Jacob Thorne. And this is what we use for our thing. So another thing we use, obviously, it's auto package. I mean, it's not an auto package talk, but let's quickly go over what it does. It's automatically, it uses recipes to automatically download software, prepare the package, maybe tweak the package a bit, and import them into Munki repository. There's a wonderful community taking care of the recipes. The recipes are multi-stage processors that can be rearranged to, and are quite flexible. So many recipes exist for existing software. If something doesn't exist for your typical software, it's relatively straightforward to build your own recipe. To add a package to the Munki repository, you make an override. An override is a file that contains a reference to the recipe, the input variables, and very importantly, it contains also the cryptographic hashes of the recipe. And this is important if you want to prevent supply chain attacks. For example, here we have like an override file for a custom enrollment package. And this is just to illustrate a little bit the kind of customization you can achieve with auto package. Here, auto package, and with the recipe, we are going to make a central API call. And we've got the enrollment ID, so we are getting the configuration back, so the name of the configuration, and we are getting the package URL, because auto package then will be able to download the package directly from central. But without changing the auto package tool, we can download the package from Central with an authenticated call. So we need to orchestrate auto package, and this is where the tool from Facebook comes into play. So what does it do? The most important thing is that it runs each recipe. It runs each recipe separately. So we loop over all the recipes that are found, and before we run the recipe, we create a branch. You have to understand that we are actually going to put the full repository into Git using Git large file storage. And this allows you to separate the changes made by each recipe, because when a recipe is run, and if it's successful, meaning if it has exported a new version of a package, then we are going to commit the changes and make a pull request. And we are committing the changes and making a pull request on a separate branch for each recipe. So, and before moving on to the next recipe, we are going to switch back to the main branch. So every single change is going to be pushed in its own pull request. There's a pull request for Firefox, there's a pull request for Osquery, and only when they are going to be merged are we going to change the actual repository. So for this, we need the pipelines, and there are two main pipelines we are going to illustrate. This is a contribution by Guccio. So the first one is to run auto package. As you can see, I don't know, it's really small, but basically it's scheduled to run daily. So because we want to, on a daily schedule, we want to make sure we get branches for the new versions of each package. What are we going to do? Well, we check out the code, we install the tools. So we install Munki, we install auto package, we configure auto package, and we run make catalogs because we want to start with fresh catalogs. We don't want to commit the catalogs into the Git repo, we don't need that. And then we run the script, and we typical GitHub workflow where we pass as environment variables, we pass the different secrets. The secrets are obviously not stored in the code, they are stored in the workflow configuration. The second pipeline, what is needed, is one to sync the repository that we have in Git or GitHub, and to sync it with our actual production repository on S3, because and this is why this one is run when we merge into main. So also in this one, main is the production branch, it's protected, and only when we merge the pull request, so for example, a new Firefox package into main, then we are going to push it to S3. So how do we do it? Same thing, we check out the code, install the required tools, the command line interface tools, the Munki. We rebuild the catalogs to make sure we have fresh catalogs and catalogs in sync. We use the same kind of authentication with AWS, where we get the credentials using OpenID Connect. And then we trigger the sync with S3. And finally, we poke the Central server. And why do we do that? Because we use Central as a thin dynamic layer between the repository on S3 and the client. So we can scope packages using tags or even sharding. So we can distribute a new version of a package on, I don't know, 20% of a fleet, for example. And so we need to communicate that the repository has been updated to Central. Are we happy with this setup? Well, it works. It does the job. It's wonderful. I mean, that we could take a project on GitHub and use it for our own. We just had to tweak little things, but it's highly inefficient. And you can guess why. The auto package cache is not used. We run this using the, again, ephemeral virtual machines provided by GitHub. So we start from scratch every time. Kanji as a as a talk about solving this issue. They released like a project called Carl, and where they, at the end of each auto package run, they store the information in the file system in a JSON payload, and before every auto package run, they rebuild a fake file system to trick auto package into thinking all the files are here. This works, but I think it could be better if, I mean, we started the discussions, we started the discussion again. In Slack, it would be better to have this integrated into auto package, like a clean cache module, a modular cache system with some backend implementation, for example, in DynamoDB. That would be really great for the kind of workflows we are talking about. And the second inefficiency is, we are storing the files both in Git large file storage and on S3. So it would be great to have the packages only in S3 and only have package info in Git. But of course, this one is a bit more complicated, maybe with content addressable packages. And I mean, if you have any thoughts about that, we'll be happy to discuss them with you. So we are coming to the last pipeline. Promise you is the last one. There's still plenty of things that we haven't talked about and that were present in the scope. For example, we have Osquery, Santa, we have the file vault, we have the recovery password, we've got all the mobile config. So, but we can do all of that using Central. 14 months ago, we started thinking about how to integrate GitOps, because we really think that it's, coming from the infrastructure side of things, we really think it's a nice workflow. And we had already Terraform for infrastructure. So Terraform allows you to describe your infrastructure as code, for example, all your AWS virtual machines, the firewall, the networks, the load balancers, and we had all of that for our own infrastructure. And we thought, like, what if we could use Terraform for the configuration of Central itself? So not for infrastructure, but for configuration. And we went on and built like an official Terraform provider for it. And now it has come a long way, and there are plenty of resources that can be expressed using Terraform for Central, and we are going to have a look at it. So here, it's really small, but here you can see this is basically like the full Central configuration for this really thin macOS client. So we've got the provider configurations. This is the official Terraform provider. We've got, so we pointed to the Central server, and we have an API token. That's it. Here we have a resource. Resources expressed as Terraform files, and we've got the mobile config. We decided to use to keep the configuration profiles in their original format, and we can inject them into the configuration. So how does the configuration look like? For example, this is a Santa configuration on the server side. So here we have one resource for the configuration, and you can see that the client mode is in monitor mode. So we are not going to block everything on the machine. If you switch it to lockdown, make sure you have code reviews for your pull requests, because it's going to block a lot of stuff. And then we have an enrollment object. And you can see the link between the enrollment and the configuration using the ID. And this is all what is provided by the Terraform language. Here we have a one-to-one mapping with the resources on the server, so we can see the same attributes and values for the objects, and we can see the enrollment linked to the configuration. We just have more attributes in the GUI because you don't have to express the attributes with default values in Terraform. So the configuration on the client side of things, we've got, again, two resources. We need to distribute a configuration profile using the MDM. So the first resource is what we call like an artifact. It's just an abstraction of different versions of the same configuration profile. Think of it as the Munki package name. And here we have a version of the artifact. So this is a profile. So we are loading the mobile config that is on disk in the repository. But there is a little trick here. We use a templating function. And why do we do that? Because we don't want to store a secret in the mobile config, but we need to authenticate with Central. So we are getting the secret as a result of applying the configuration you've just seen in the slide before. And we can inject the secret without, we can inject the secret directly in the mobile config. How does it work? Yeah, in the mobile config, you can reference the variable that is passed to the template function. So this way, you can keep your config clean, and you can even share it. We share it with our customers. This is really nice. This is one of the nice features of Terraform. For the Bootstrap package, here we can see, again, we have an artifact. There are two extra attributes of this artifact. We want to push it as early as possible, so we make sure that it's installed during setup assistant, and we have a requires attribute, and this one is also a feature of Central, where we can say we want to install this only after another artifact is installed. So we make sure that the configuration for Munki is pushed before we install the package. And then we have a version of the package. So here is, for example, a bad example of not having secrets in your code, so I had to blur it, but actually you could use a variable in Terraform so that you can keep this quickly. But here we reference the package we have built using the first pipeline, and we have a hash of a package to make sure that we download the right package and to tell Terraform when changes are required. And then we bring together it together using blueprints. So we have a name for the blueprint, basic configuration about the client. So this is what the client, this is everything we are trying to push to the client. So there's a little bit of configuration about the inventory collection. Collect the apps, collect the certificates, collect the profiles using MDM. There's a reference to a file vault config, a reference to a recovery password config. So the file vault config is an abstraction of what is necessary. We don't, I mean, you could still push your own mobile config if you want, but Central has a way of making sure that file vault is enabled and can push the mobile config for you. So here you have like classic thing where we force it at logging without bypass attempts. We want to destroy the key on standby, and we don't want to show the recovery key to our client. And on macOS 14, we are going to try to enable it during setup assistant if possible. The recovery password here is a classic one. When you use default values, you just have to name it, and that's it. So. And this is where we link the Bootstrap package artifact to the blueprint. So here we reference the artifact, we reference the blueprint, and we tell it to distribute to all the macOS client. Another one, compliance checks. So here we have Osquery compliance checks. It's an Osquery query, part of the pack. And the important thing here is this is how we do Osquery compliance checks in Central. If you have a query that can output an extra column with OK or failed, then Central can automatically keep track of it and show it in the GUI as a compliance checks for each machine. Metrics are exported for every compliance checks in Prometheus or this kind of stuff. You've got reports. I mean, all the good stuff. Yeah. And yeah, it's scheduled, so it's linked to a pack. It can be managed using Terraform. So the pipeline, we need to apply all this stuff, but here we benefit from Terraform. You no need to make a custom deployment script. You don't have to check if a resource exists, check if you have to modify the resource, or stuff like that. You can directly use Terraform because we have Terraform plan to calculate the changes that are necessary, and Terraform apply to apply them. And since Terraform is a very well-established system, there are already plenty of integrations in place, and we are going to use the GitHub Terraform Cloud integration. So a quick example. After the talk yesterday from Patrik, is probably not the best. I don't think it's good to disable the background task notifications, but here we are. We are going to disable them. So don't do that. So we are going to add the 4 resources required. So artifact, profile, and blueprint artifact. We are going, so we add them as code. It's the same example as the Santa configuration on the client side. We make a pull request, and then the Terraform integration is going to be triggered. So in that case, on the pull request, we make a Terraform plan. So we calculate the changes, but we don't apply them. At the same time, oh, okay. Okay, and at the same time, there's a mandatory code review, and when both of them are okay, you can check directly in GitHub the different resources that are planned to be created. You can merge a PR. And when you merge a PR, this is Terraform Cloud Interface. You can see the resources being created. And this is the one-to-one mapping in Central. And if you wait long enough, it's going to be installed on your devices. We use like declarative device management even for legacy profiles. That's it. I hand it over to Johannes with only a few minutes left for the conclusion.
Thanks, Eric. Yeah, okay, so we talked about the end result here. Like, it works as expected, and that's great. But we should also look at our way here so we get a more complete picture of what happened. We started off from good conditions. Central was a good platform to start with. We had reached MVP status for the MDM lately, and it integrates well with the open source agent modules. And the API is good for GitOps workflows. We had demonstrated some Terraform workflows for our talk at Mac DevOps YVR in June. And we could probably have done a good talk on how Osquery, Munki, and Santa can complement any MDM to, as a good solution. But conferences like this one remind us of why we are doing this. It's an exciting time to be part of this community right now. Everybody's buzzing about GitOps and DDM, and it seems like we're entering a new era of device management for Apple. And we hope that we can make an impact on how we deal with the challenges of modern device management, just as we learn from other speakers here. And for this talk, we wanted to push ourselves to build something special, and to define a whole client as code sounded very inspiring, and it seemed doable. What could go wrong? From the moment we set out, it was quite a roller coaster. Started with our own Central deployment. We did have Terraform modules for that, but what about the certificate authority? Not only did we have to pick and install one, but we had to find a way to expose it with a SCEP proxy as well. And that meant a lot of work even before we started to define the client. Next, we realized that we were missing features in Central itself. We didn't have a way to manage an enterprise app with Terraform, and we didn't have an API for it. And that was a lot of work again. We added API endpoints, updated the Go client, then added the resources to the Terraform provider. And other things didn't go as well as we had thought at first. Making sure that Munki config is distributed before the enrollment package proved difficult. And to round things out, we even stumbled on a DDM bug that made it impossible to update a legacy profile in macOS Sonoma. In the end, it's probably fair to say that we've done it, and we've shown that we can define a functional macOS client as code that meets the requirements we scoped out. The tools are set up, and our hardening is in place. We've got workflows and pipelines that are positively boring. They work. Racing through all this, the tight deadline was unnerving and challenging, and we probably suffered from some hubris when we decided that we are going to hand this topic in. And the abstract became a self-fulfilling prophecy, really. Like, how did we think this was a good idea? it was a bumpy ride. But then again, at some point, it was kind of cool how things started to fall into place. Like some things are really felt like they were just meant together to work together this way, and they connected, and the sum's kind of greater than its parts. That felt pretty cool, and this is why we think that we're onto something here. Almost all required resources are managed with GitOps, from the central infra to the macOS client config, and this is reproducible and shareable and definitely beyond the proof of concept, and we have really good foundations to iterate upon now. So after this adventure, we think that Central is in a better place as an organization and as well as the software. The client is obviously a work in progress, and we've got to do lots of daily business with it now. We've got to harden the payloads, we've got to tweak the compliance checks, we've got to polish the thing, but we've got a great setup for testing. And that's not only for new functionalities, but it's also what it's like to maintain a fleet of Macs with Central long term. So yeah, hopefully we've validated that Central is up to the task and demonstrated that GitOps is, to manage macOS clients, doesn't just make for a good conference talk, but that's actually something great that you might want to explore. Like we said, everything connects here. And yeah, so what do you think? Would it be too much to introduce Terraform with another configuration language for your setup? Do you think that's too much work for too little reward? Or is that a cool solution? We'd really appreciate to hear your opinions. We're very curious to hear them. Please tell us in the hallway. We'll be here the whole week. Yeah, and last thing, since we're on the big stage, please allow us to use this opportunity for a quick preview of the things that are coming for us. We want to solve the Santa Rules Management Challenge. Many of you have expressed interest in the kind of workflows that Upvote used to have, and we want to implement a voting system for application control. And we also want to allow for better integrations with the IDPs. Authentication with SAML and OIDC is nice, but what if Central could act as a SCIM server? Yeah, and finally, the last big task for us is for the next years, probably, we want to leverage DDM as much as possible. That's it. Thank you very much for listening.